All right, now we've seen how things move in a straight line. And we've seen that there are three quantities that control the motion. You have the force that you push the cart with, like the little plunger. You have the mass, which is how much stuff there is in the cart or on the cart. And you have the motion, how much it changes its speed. Those are things that happen in a linear way, straight line. What happens when you go around and around? Now I've got a bicycle wheel with handles on it. I don't think I want to ride this bike, but it does show me some interesting things about what happens when you talk about force and mass and motion in a circular way. Because see, I can spin that wheel and it goes around and around. It has a velocity which could be measured in revolutions per minute, RPM, or it could be measured in how many units of degrees, like 10 degrees per second or something like that. How fast it goes would be measured in circular motion. And the mass would be part of the picture here. The mass, the wheel has mass. So just like the cart, there's a certain number of molecules that make this up. And to make it move, I put a force on it. Watch. But you know what's interesting about this is that the wheel demonstrates a whole different type of motion. Because you can see it going around and around, but what you can't see is that I'm having to put some force on it. Watch what happens if I take this wheel and set it over here so I'm not holding it. Wow, that's kind of different, isn't it? Now, the first law says it'll stay in motion until something acts on it from the outside. That's working, isn't it? It's spinning, it's staying there by itself until something happens from the outside. Now, one outside force that's working on it is friction. Things are rubbing on it, so you can see it slowing down. And of course, if I pick it up, that stops it too. But you'll also notice that it wobbles. Why does it wobble? Because the weight here is not distributed evenly. This wheel has been dropped a few times. The axle has been bent. There are some differences in weight around the outside, and so it wobbles. What can you think of that does this? Well, yeah, your bike, your car. How about the earth? The earth spins like that. So does the earth do this? Yeah, it's got a name. It's called nutation. It wobbles like that because the earth is not perfectly circular. It has some bumps and mountains and things like that on it, and so it wobbles a little bit. There's something else that happens here that is really interesting. All right, now I'm going to set it down at an angle this time, and look what happens. This is called precession. And it happens because the axis is spinning so that the weight is not right on the axis, vertically like that. The weight is off, and the weight pushes it around, and the wheel moves. It precesses as a result of that. Does the earth do that? And the answer is yeah. Yeah, the earth does that. The earth precesses. What that means is that the axis of the earth pulls around like that. So right now, the north pole of the earth is pointed at the North Star. Well, sort of. It was actually closer to the star when they set that up not too many years ago. But now it's moved away from the North Star. And eventually the North Pole will point long distances away from where the North Star is. This describes the motion of the earth. I want you to watch what happens here that may seem almost to defy gravity to you. I'm going to spin the wheel, just like I've done, and I'm going to hold it in my hand just like that, except I'm not going to hold it. Watch. Ah, there it goes. And look what happens. Wow. If I put it in my other hand, it goes the other way. Now this is called inertia. And when you deal with circular motion, instead of just having momentum, you have some other things that happen. So circular motion has some really unusual things with it. It's not quite as simple as straight line motion. If you put the axis straight up and down, however, the wheel can be used for some very productive things. You know what this is? I suspect you've played with one of these. It's a little thing called a gyroscope. And the gyroscope utilizes what we just saw here. You get this thing spinning really, really fast, and the gyroscope will sit perfectly straight up and down like that. If you put it over in an angle, then it will precess around like that. It will do the same thing that we saw the bike wheel do. So how do we use that? Well, let me give you an example. This is a gyroscope, same thing as this, out of a missile, out of a tailless missile. And what happens is that inside of this thing, there's a spinning wheel. So what they do is when they're getting the rocket ready to go, they point this thing the direction that they want it to go, and they have electronics around this so that if something happens to move the spaceship, it will close a switch. And when the rocket takes off, if the rocket starts to veer off course, the gyroscope will stay right where it is, and that will cause the rockets to fire and push the missile back on course. So gyroscopes are used in spaceships. They're used in airplanes, in submarines, in lots of places where we want to be sure we go in the right direction. It has a very, very important use. Now, there's another interesting thing that happens with circular motion, and which controls the way in which things work upon the Earth. I've got a cork here. It's on a string, held inside of a little handle that I can hold on to. And down below, I can put some weight. So when I spin this thing around, I can get a balance between a force that is working to push that cork out and what is happening down below. Now, the force that pushes out is called centrifugal force. Centrifugal, center fling. By the way, there's a word that describes what the string is doing. It's causing centripetal force, center seeking. And these forces are in balance. When I get this around with everything put in here, the weight's not going up or down. Now, if I slow down, look what happens. And you can see the weight is going down, isn't it? I wasn't going fast enough. So centrifugal force is caused by how fast I spin this thing around. Suppose that I change the radius and nothing else. Okay, I'm going to hold it this time, spin it around at a certain speed, and we'll go real, real slow here. Watch what happens if I do nothing else except pull down on the string and make the radius smaller. Did you see what happened? When I have it out here, it's going very, very slowly. When I pull it in, it goes faster and faster. And actually what's happening here is that the momentum, remember we talked about momentum, it's mass times velocity. The momentum has to change because I've changed the dynamics of the arrangement of the string and the weight and the radius. And all those things have to work together. Did you ever see that happen? Yeah, you ever watch a figure skater? When a figure skater goes into a spin, they do exactly what I just showed you. They start out with their arms and legs out. And then when they want to spin real fast, what do? Yeah, they tuck their arm and their leg, and it goes faster and faster and faster. And the smaller the radius becomes, the faster they spin. We even use that sometimes in clutches and things in cars to make them go faster or slower, to control them. Now let's try a couple of other things here. Let's suppose instead of using that force, let's suppose we use a smaller force. And I want to get this to balance. Look what I have to do. Going a lot slower, right? If I go fast like I was before, you can see it change. And if I go too slow, what would happen is that, again, it would slide down. And you can see that happening now, going too slow. There's one speed that will make it move at just the right force. So, how does this relate to the solar system? Well, the sun pulls on the Earth. The Earth has a certain mass, and it flies out from the center. The distance out has to be just exactly right to make it work. Now, let's suppose we do a little experiment here. What we're going to do is we're going to go back to our first weight. We're going to spin this around. Okay, that's how fast I have to go to keep that planet out there going at the right speed. All right? Now, let's suppose that instead of having the Earth, that I had Jupiter out there at the same distance. As a matter of fact, there's much greater difference between Jupiter and the Earth than there is in these two corks. But if I did what Jupiter really was, I couldn't even control it. Watch what happens this time. What I'm going to have to do to make this work? Well, I'm having to go very, very slowly, aren't I? Nowhere near as fast as I did before. If I went as fast as I did before, you can see what happens. The thing takes off. So a planet as big as Jupiter, as far from the sun as the Earth is, would fly off into outer space if it was traveling at the same speed. So the laws that God has put in motion allow the planets to go along at just the right speed. If a planet is big, then it has a lot more outward force, and you have to slow down its motion. This is all part of how the solar system is designed. And you can see that the forces that are at work here are ones we can actually demonstrate. I hope you'll set up something like this and try it for yourself and see how it works. Now, one of the things we've said is that you have a thing called angular momentum that is controlled by the dynamics of the object, how the object is made and where it spins and what it spins around. And sometimes strange things can happen when things aren't perfectly lined up. You've already seen the bicycle wheel go around in some rather strange ways. Take a look at this top. Now this top, and here's one that's open so you can see this. This top is just a plain ordinary top, okay? There's nothing fancy. The top is just an ordinary top. But watch what happens when I spin this top. Wow, it turns over. Now when it slows down, it eventually will right itself. And let's watch that again. You see, what's happening here is that the axis is not lying straight up and down. The center of gravity of the top is not right on the axis. So if you look at it, you can see that the top is not pointing straight up and down. So it's just a little bit off center. So when I spin it, the centrifugal force that we saw a minute ago pushes the weight to the outside. Then you really have an unbalanced situation because the weight is way off the center of spin and it will send it right on up so it sits on the smallest point it could find. All right, now we've modified our little top a little bit. We put a toothpick in there so that instead of this thing spinning on a round surface, it can spin on a point. Well, that's just what normal tops do, isn't it? A little bit of precession there, a little bit of nutation, like what you and I talked about with the bicycle wheel. Now, I'll take that out of there and watch what happens. And you can see that the top will turn over again because it doesn't have that single point to spin around, so that it can keep all of the forces perfectly lined up. When God designs things, He has them arranged very precisely, and any little tiny change can make a huge difference in the way things behave. Let me show you one that is even more complicated. This is just a plain old piece of plastic. And you'll notice that the piece of plastic, when you spin it one way, spins very nicely about the point, just like you would expect it to. But watch what happens if I spin it the other way. Isn't that strange? This doesn't want to go that way. The way it wants to spin is that direction. I know some people that are like that, don't you? They want to go one way. You try to make them go the other way, and they'll force their way back the way they came. Again, the reason this happens is because the gravity has to be lined up, or some strange things happen with the momentum. When you get into high school and college, you'll study why that happens and how that happens. But I just wanted you to see it, because realize that when God designed the earth, He had to be very careful about how the earth was arranged, how it was put together. You just can't put anything up there and have it work. One of the ways we can know there is a God is through the things He has made. And one of the fun things about studying science is to see all the special things that happen in space to make things work the way that they do.